Good evening, boys and girls. So what I'm going to do tonight is I'm going to go through two questions. This I took from the Gauteng June 2024 paper. So I'm going to go through this 1.3. Then I'll also go through this one as well. That was the June 2025. That's the other question paper, the other question that I'm going to go through as well. So I'm just going to do two questions. The reason I'm doing this is just for understanding purposes, because I'm just trying to simplify mid-latitudes in a way, but guided by the past exam papers. That's the strategy that I'm trying to use. So I'll do those two questions. Then I think by tomorrow or anytime this coming week, then I'll start with the tropical cyclones. So this is my last paper, and as far as mid-latitude is concerned, then I think starting from next week or early Feb, I'm going to start with the lives, where I'll be also revising past exam papers in preparation for end of term 1 test. So let's go through the paper now. So the first thing that I usually do when I'm going through these past papers, the first skill that I try to instill in you guys is question interpretation. Question interpretation is very important. You might have all the information, but if you fail to interpret the question, then obviously you won't get the answers. You won't get the correct answers. So that's the first thing that I usually try to do whenever I'm posting or I'm doing these lessons. Okay, so the first thing, let's just try to analyze the diagram as it is. It's very important. Do not just rush to start answering the question. You have to analyze. You have to understand the diagram, because this will help you to have answers that are correct. Refer to the cross-section of an occluded front depicted below and answer the questions that follow. So the first thing that we have to take into consideration is what type of an occlusion it is. Remember, we have got the cold front occlusion, we have got the warm front occlusion as well. So you need to be aware as in what type of an occlusion it is. That is the first thing that you need to be aware of, what type of an occlusion it is. So when you're looking at it, you will see the first thing is, this is your cold front. So this is your what? This is your cold front, okay? This is your what? This is your warm front. Okay, these are the two things. We just want to take note of what we have. Obviously, in between here, where we have got warm air, we call this the warm sector. This is the warm sector. Okay, so what we have in as far as this occlusion, front occlusion is concerned, we want to see what exactly we have. This is your cold front. So behind the cold front here, there is cold air. There is cold what? Air. Then ahead of it here, which is ahead of the warm front, there is cool air. Okay, there is what we call cool air. This one we also regard it as the what? The cool sector. Okay, that will be the cool sector. This one will be more like the cold sector. Okay. This will be like the cold sector. So this is what we have. Let's see something that we can also pick from this diagram. You can see which front is touching the surface. The cold front is touching the surface. So you can see the cold front is touching the surface, okay? Cold front is what? Is touching the surface. So these are the things that we have taken note of. Our cold front is touching the surface. That's number one. Number two, we have got cold air behind the cold front. The warm sector obviously it will always be here. Okay, it only narrowed as the cold front catches up with the warm front. Okay, but your warm sector will always be in between. Then what else do we have here? What we have got cool air, which is your cool sector. So the difference now in when it comes now to your cold front occlusion, there is always, they will check the position of your cold air It's behind the cold front. Then ahead of the warm front, there's cool air. That's what happens, okay? You also check the type cloud. This is your cumulonimbus clouds. You can see this is your cumulonimbus cloud, okay? Cumulonimbus cloud, okay? This is more like your cumulus clouds. This is more like your cumulus clouds. So you have to take note of that. Okay, so the front is moving in this direction. So we have actually analyzed the diagram where we have find out that we have got the cold front here. There is cold air behind the cold front. Here the warm sector will always be in between. We have got our warm front and there is cool air ahead. And also that our cold front is touching the surface. This is what makes it a cold front occlusion. The cold air is found behind the cold front, causing the warm air to be uplifted along the cold front. What else do we have? The cold front, it will undercut the warm front. Of course, we're looking at all those things. So this is what you need to know in as far as the diagram is concerned. So let's go through the questions now. So the first question reads, identify the type of occlusion shown on the sketch. We have already answered that question. Which means it's your what? Cold front what? Occlusion. It's an old front occlusion. This is an old front occlusion. From the analysis that we did, you can see that provides evidence from the sketch above to support your answer. So what supports that is a cold front occlusion? We have already said that the cold front is touching the surface. So that's evidence. That's an evidence that shows that it's a cold front occlusion. Remember, you need only a point, okay, to support or to substantiate that is a cold front occlusion. So the cold front is touching the surface. That's number one. What else can you talk about? The cold air undercutting the warm air and the cool air in front. The position of your cold air, it also supports because it's behind the cold front and the cool air is ahead of the warm front. So that also supports that is a cold front occlusion. We have written that already on this diagram. Cold air behind the cold front, then cool air ahead of the warm front, okay? So this also helps to support that, to substantiate that it's a cold front occlusion. Let's move on. Identify the sectors A and B respectively. I have already answered that question. Can you check your A, cold air, cold sector, B, cool air, cool sector? I've already answered that question, okay? So they have got A is the cold sector. This one is the cool sector. So that's how you respond to that question. Let's move on. Discuss how the type of occluded front shown in the sketch above is formed. How is a cold front occlusion formed? How is it formed? How is it formed? How is a cold front occlusion formed? That is what you're supposed to right now, which has got 6 marks. So I'm going to go back to the diagram so that I can explain using the diagram. So the first thing you have to take note now is the cold air mass that is behind the cold front. It moves faster than the warm air mass because the cold air is what? It is heavier, it is dense. So what it does is cold air masses move faster than the warm air mass, which means at some point this cold front, this steeper pressure gradient here, so which causes it to move faster so that it catches up with the warm front. That's what is happening, which means the cold air, as it is moving, as there is a steeper pressure gradient behind this cold front, it means now the cold air, what does it do? It undercuts the warm air and cool air ahead of it. That's what it does. So it undercuts the warm air and cool air ahead of it, which means the cold front now overtakes the warm front. Then cold air remains on the surface. That's what happened. Let me take you through again. Cold air masses moved faster than warm air masses, which implies that there is a steeper pressure gradient behind the cold front. Cold air masses move faster than warm air masses, which means that there's a steeper pressure gradient behind the cold front. The cold air, because it is heavy, it undercuts this massive upliftment of our warm air and the cool air that is ahead of it, because this air have got difference in terms of temperature, in terms of their density. This is more dense, this is less dense. Even the cool air as well is less dense as compared to the cold air. So there's massive upliftment now of our warm air and cool air ahead of it. As that process takes place now, which means our cold front will now overtake the warm front, and the cold air will now remain on the surface. The cold air is now remaining on the surface. That's why you see the cold front is touching the surface here. That's what happens. Okay, that's the formation. So we have said that the cold air mass move faster than warm air mass. The cold air undercuts the warm air and cool air ahead of it, and the cold front overtakes the warm front, then the cold air remains on the surface. That's why in a cold front occlusion, the cold front is touching the surface. That's what happened. Let's move on to the next one. 1.3.5. It reads, account for the weather associated with the occluded front shown in the sketch above. So the weather conditions that are associated, the weather associated with the occluded front, which is a cold front occlusion. So these things, guys, it's on the diagram. It's a matter of just talking about what you can see on the diagram here. What do I mean by that? Obviously, we are likely to have unstable weather conditions, which means we have got things like we can have possible thunderstorms, cold air undercuts warm air, forcing it to rise, clouds form resulting in rainfall. This is what is likely to happen. You can see with the cumulonimbus clouds. What else? It can also bring cumulonimbus clouds. These are the things that you are seeing associated with heavy rainfall. These are the things that are evident that you can see. Then cold, dry weather behind the cold front. Cold, dry weather behind the cold front. Okay, cold air carries less moisture, which means that's what will happen now, because cold air carries less moisture. That's what will happen. Cold, dry weather. There's cold, dry weather behind the cold front because it carries less moisture. So we have talked about possible thunderstorms. Why? Because cold air undercuts the warm air, forcing it to rise, and clouds form resulting in rainfall. It also brings, you can see there's cumulonimbus clouds here. Associated with heavy rainfall. So those are some of the things that you can actually include in your explanation. So in short, guys, it's a matter of your ability to analyze the diagram, what is shown by the diagram. Most of the answers, they're supposed to come from the diagram that you have. They are supposed to come from, even if you are given an infographic, you have to do your analysis there. And take note, guys. And you see here is written cross-section, which means your cross-section is not supposed to show the symbols. It's not supposed to show the symbols for the cold front and also for the warm front. That's what makes it to be a cross-section. As long as they mention cross-section, make sure you do not put the symbols. Okay, let's move on to the next question. The next question is coming from June 2025. Remember the first one that we did, it was actually derived from a 2024 June paper. Let's move on now to this one. Refer to the synoptic weather map below on mid-latitude cyclones. Let's try to analyze the diagram. What is it that we can see from this diagram? Number one is a synoptic weather map. What season is being shown by this synoptic weather map? Number one, I want you to take note of the date. What date do we have here is 3 June 2024. So obviously it's in winter. It's in winter. That's what comes to your mind. Number two, what is it that happens during this season in winter? We have got the changing or the shifting of position of our ITCZ. So we are saying that our ITCZ, it shifts its position. Okay. It shifts its position, which means now it's on top of the equator. It's in the northern hemisphere. It's on top of the equator. It has shifted its position, which means when the ITCZ shifts its position, it means our South Atlantic high and our South Indian high also move further north. That's what happens in winter. They move further north. That's what happened now, which means our two high pressure systems, that is your South Atlantic High and your South Indian High, they follow the position. They move further north, following the position of our changing position of our intertropical convergence zone, because now it's on top of the equator. So they change their position, which means when they change their position, what will happen now? Of course, you can see now our cold front, or the mid-latitude now, is able to affect the weather in Cape Town. Why? Because they have shifted their position, you understand? And also in the interior here, if it's winter, we have got an edge which shows that there is too much subsidence. The Kalahari is very active. The Kalahari is very active. That's why mostly we have got only rainfall in Cape Town, but not in the interior, because our Kalahari, which is a high pressure system, is very active. You can see the approaching of the mid-latitude. Why? Because the movement of our South Atlantic High have paved way for the mid-latitude to affect the weather in Cape Town. They have changed the position towards the north. You understand? That's what is happening there. All right, what else do we have? Which means these are your mid-latitude. Remember, we talked about the stages of the mid-latitude, which is made up of the initial stage. Which other stage? We have got the development stage, we have got the mature stage, and the occluded stage. Of course, there is another stage that is not much talked about, the dissipating stage, where warm air is uplifted from the ground and rainfall decreases or stops. So the cyclones, what they usually do, I've talked about the different stages of our mid-latitude cyclone, but what they usually do is they appear in families. We call them the family of cyclones. You can see here we have got the different stages of our mid-latitude cyclones that are shown here. This is what we call a family of cyclones. You will have this on your synoptic weather map. You can have the different stages, like you can have your mature stage, you can have your you can also have your occluded stage. Sometimes they can even show you the initial stage or even the development stage. So these are the different stages that you can actually have in as far as your mid-latitude are concerned. You can see you have got differences. Okay, you can see here, as you can see, we do not have clearly defined the cold front and warm front. As you can see, what is being depicted here, you can see here as well. But when you get to this now, it's now clearly defined cold front and warm front, which will suggest that this is more of your mature stage, because there is clearly defined cold and warm front, okay, as compared to the other stages. So basically that's what we are talking about. Of course, that's what we are talking about. So let's go through the question so that we can be able to answer. Okay, what do we call a series of mid-latitude cyclones in succession? Because we call this a family of cyclones. We call this a family of cyclones. They are in succession, which means they are in stages from one stage to the other. That's what they mean when they're saying in succession. They happen in families. That is a family of cyclones. Okay, if you find them, a series of mid-latitude cyclones in succession, that is a family of cyclones. Okay, name them front A and sector B. So this is what you have to take note of. You are just naming the two things. What guides you is here. We need a front in as far as A is concerned. A, what we have here, A is a cold front. That is a what? A cold front. Then B, what we have, B is between. You can see here that makes it your what? It is the warm sector. That is the warm sector. That is your warm sector. That is your B, is the warm sector. This is your cold front. That B is the warm sector. Let's move on to 1.3.3. What influence does the South Indian anticyclone the South Indian anticyclone, as shown on the synoptic weather map. We have on the path followed by the mid-latitude cyclone. So we are saying now we have got these two high pressure systems, the South Atlantic and the South Indian. I have already explained to you that they change their position with the shifting of the intertropical convergence zone in winter, which means if our ITCZ have shifted on top of the equator, it means now the two high pressure systems, that is your South Atlantic high and your South Indian high, they move further north. They move further north. And you can also see now when you look at your two high pressure system, this one has already opened way. That is your South Atlantic high. That's why Cape Town is able to be affected by the mid-latitude. But this is not what is happening on the eastern side, or what we call on the southeasterly side. What is happening in as far as the South Indian high is concerned? That's what we have to attend to, because the question is saying what influence does the South Indian anticyclone, as shown on the synoptic weather map, have on the path followed by the mid-latitude? How does it affect the movement of the mid-latitude? That's basically what you are supposed to talk about. So you can see now it has got a blocking effect. It has got a blocking effect. Even though it has moved further north, what will happen is that it blocks the blocking high pressure, they block high pressure, their path to the east. You remember it usually move from west to east, so this has got a blocking effect. It blocks their path to the east. That's why they end up moving in a southeasterly direction. That's how they end up moving in a southeasterly direction. We are looking at this, okay? This is your east. They are moving towards this direction. Why? Because of the presence of our South Indian high, which is as a blocking effect. That's why they are moving in a southeasterly direction. You can see I've put my cardinal points north, south, west, east, which means they are moving from here in a southeasterly direction. So they have a blocking effect which caused them to change their path to the southeasterly direction. That is what happened. That's how you respond to question 1.3.3. What influence does the South Indian anticyclone, shown on the synoptic weather map, have on the path followed by the mid-latitude? So they are changing their direction because of the blocking effect of the South Indian high to a southeasterly direction. You can see where they're coming from. Usually we say it moves from west to east, but now it has changed. Now it has been diverted to southeast because of the blocking effect of our South Indian high. Danko. Let's move on to the next question. The next question reads, the mid-latitude cyclone at sea is the cold occlusion stage. Draw a labeled cross-section at sea on the synoptic weather map. Marks will be awarded for the following. So you have already been told that it's a cold occlusion. So what is it that you need to do now? You have to know that since it is a cold occlusion, it means now your cold front is supposed to touch the surface. That's what it means. So what do we have? What is it that we are supposed to do? Draw a level cross-section at sea. In synoptic weather map, marks will be awarded for the following, which means these are the things that you are supposed to show. Number one, indicate that it's a cross-section. Indicates that it's a cross-section. Okay, it's a cross-section at sea. At sea. That's what you need to indicate. So I have drawn now my cold front and I made sure that it touches the surface. Then I'll have my warm front here. So what is it that I'm supposed to show? I'm supposed to show cold air. Remember, on a cold occlusion, there is cold air behind a cold front. What else am I supposed to show? I'm supposed to show the cool air. There is cool air ahead of the warm front. That's where my cool air is E, which is here. Cold air is there, which is behind the cold front. What am I supposed to show? Obviously, your warm sector will always be in between. All right, so I have shown what I'm supposed to show, the cross section at C. I have indicated where my cold air is. I have indicated my warm sector and also my cool air. So it's a matter of you knowing what is the position of our cold air, where is our cool air, and where is our warm sector. That's how you are supposed to do it. And make sure you also indicate that it's touching the surface, because you also make sure that you do the right things. Okay, let's move on now to the next one, that is 1.3.5. It reads, account for the development of weather that Cape Town experienced on 3 July 2024. How do you account for that? How do you account for that now? What causes the floods? What caused the heavy rainfall? That's what you need to account for. That's what you need to account for. Because we are saying that account for the development of the weather in Cape Town on 3 July 2024. Okay, that was experienced, the weather that was experienced during that time. How do you account for it now? So the first one is heavy rain was due to the formation. Heavy rain was due to the formation of cumulonimbus clouds. So the heavy rainfall due to the formation of cumulonimbus clouds. Cumulonimbus clouds. Okay. Cumulonimbus clouds, that's number one. That's something that you can actually indicate. If rain was due to the formation of the cumulonimbus clouds, what else can you talk about? Obviously, there is steeper pressure gradient behind the cold front. So we are saying the strong winds result in the upliftment of the warm air. The strong winds. What was the impact of the strong winds? So we are saying that warm air, let me make sure that I don't mix it. Warm air was uplifted. Warm air was uplifted. That's what happened. Okay, hail due to vertical extension of the cumulonimbus clouds. There was also a decrease in temperature because of the cold air that is behind the cold front. Those are some of the things that you can actually talk about. So in short, I'm saying that you can include, if you're accounting for the development of the weather in Cape Town that was experienced on 3 July, you can talk about the heavy rain. It was caused by the formation of the cumulonimbus clouds. Okay, there is strong winds behind the cold front. Those strong winds, what was the impact? Due to the steep pressure gradient, which result in the upliftment of the warm air. And then hail was also due to the vertical extension of the cumulonimbus clouds, which means you'll have a cumulonimbus clouds here, vertical extension. That's why we also have hail there, a form of precipitation. Then also here behind the cold front, of course, there was a decrease in temperature. Why? Because there is cold air behind the cold front. So those are some of the three things that you can actually include to get all your marks. So this takes us to the end of our two questions that covered this question, which all of them are all about synoptic weather map. So I think I have done justice in as much as mid-latitude is concerned. I explained most of the things that are important, that is from the alternative names to the characteristics, to the conditions, the stages. Those are the most important stuff. So you have to know that the most assessed stages in as far as the mid-latitude is concerned is your mature stage. You have to know how to draw the cross-section, and make sure when you are drawing the cross-section, you do not include the symbols. So boys and girls, thank you so much. This is all for today. Thank you and good night.